Hello, everyone, and welcome to another mini sky tonight. So I had a couple of viewers ask me about black holes. What are they? How do we see them, etc. So I decided to break this into two-part segments. The first part being describing what black holes are and some of the basics of black holes, and part two being the history of our understanding black holes and what we know today. So let's dive into the concept of a black hole. So before really kind of explaining it, we have to understand this concept known as space-time. Einstein came up with this theory that everything exists in its own space in its own time, and that everything exists in multiple dimensions. In this particular case, he noticed that everything existed on an X, Y, and Z plane, but more importantly, a time plane, meaning that you have an object, let's say, for example, a three-dimensional object with an X, Y, and Z that's go in its own place. But time is moving forward as a X box. So even though that box still is in the same position, time has moved forward. So therefore, in the time dimension, that object has stayed in a certain position. So everything can exist in this multiple dimension and keep moving with it. And gravity can alter these dimensions because gravity has a unique force that can alter any of these dimensions. And he called this idea of these multiple dimensions space-time, where an object can exist in a certain space over a position of time. So think of it this way, kind of like everything gravitationally affects space-time to where it pulls it in towards it as we're moving in time. Or sometimes I like to think of it as a rubber sheet. So what are black holes? So imagine an object is so massive that on this rubber sheet that it distorts the fabric of space and time, that all that gravity, as you kind of can see here, is literally being pulled into the center of this object so much that it literally bends it out of shape completely. Now, all objects bend space-time a little bit, but imagine it being bent so much that it can't escape. And that's what a black hole is. Basically an object, or in this case, the death of a star that distorts space-time so much it breaks it down to a single point. And as light travels across space-time, because light goes at a certain distance and it travels in X, Y, and Z over a distance of time, as it's going along its own path in a straight line, if it gets close, it could be distorted in some way. It can either basically be bent and or fall into the black hole and never escape, because nothing, not even light, can escape it, because the escape velocity of a black hole is much greater than the speed of light. Now, there are two types of black holes. You get stellar mass black holes, which are usually created by the death of a star, which we'll get into how you get these black holes. And then you have supermassive black holes, which are usually the result of multiple different black holes merging together. And yes, we have detected that. So to kind of go back on the space-time continuum, so everything, imagine kind of like a rubber sheet. And if you put an object towards the center of that rubber sheet, everything kind of gets distorted towards the bend in the fabric of space-time. So, and Einstein's idea, that's why things go into orbit around things, because they're following along the path that they normally would go, but that path has been distorted by the object, the more massive object. So in the case of the sun, it distorts it a little bit, but not too much. In the case of a neutron star, which is incredibly heavy to where 1 teaspoon of a neutron star weighs roughly about a ton. Yeah, just a teaspoon would weigh over a ton. Crazy. Now, a black hole is a whole unique beast. It distorts it so much, it literally breaks it down to a single point where nothing can even escape. So how are they formed? Well, as I mentioned, it comes from a star. Now, an average sized star like our sun, what will happen as it's going through its nuclear process of nuclear fusion, it will start running out of hydrogen to be able to fuse to produce light, heat, and energy. And so it'll start to try to fuse the next heavier element, which in this case is helium. It'll try to start fusing helium, but it doesn't need the excess hydrogen, whatever little bit is left. So it'll puff up into a red giant star with the hydrogen level on the top and the core fusing helium. And it'll keep fusing helium, and then it'll start fusing carbon, nitrogen, and oxygen. But eventually, it's going to start running out of that excess mass. So for a star like our sun, what will happen is it will collapse down into a little star known as a tiny white dwarf. And then it will puff out its outer layers into a planetary nebula. Basically, it's a cosmic ash ball around a tiny little white star. So nothing major. When you get black holes, however, it comes from stars that are much more massive. Something that, say, roughly about the mass of 50 times greater than our own sun. So you take a massive star that is going through hydrogen, and then it puffs up into a red supergiant because it has enough material to keep fusing helium. But then it keeps fusing down further beyond carbon, nitrogen, and oxygen. It starts going down into some of the metals. And when it starts going in some of the metals like iron, that is usually the sign of cataclysmic fallout for a star, because the amount of energy it takes to fuse iron is a whole lot greater than it gets out of it. And the reason being is because metals like iron attract electrons very easily. Hence why we use iron in a lot of different materials for electricity, like in some of our wires and stuff. It's able to easily conduct electricity. And because of that, since all these electrons are on top of the surface of the iron that's trying to fuse, and it easily passes electrons, it's harder to squeeze and ram those electrons together because there's so much force being wanting to naturally repel itself to the electromagnetic force. And because they want to repel, you have to push so much energy into ramming them together. And because so much energy is being put into it and not getting it out, it starts going through basically a nuclear meltdown. Because the amount of energy is putting it in is not receiving outward, so it starts collapsing in on itself. And to make matters worse, it goes through a process known as neutrinoization, where basically neutrons are being excessively produced. And those neutrons, meaning they have negative charge, don't attract to anything at all, and they don't like to be close to each other. And it takes much more force to push these neutrons together as well. So you're having all this excess buildup, and it has nowhere to go. It can't be squeezed any further. So the star starts to pulsate as it's trying to fuse those things together. And eventually it goes through a process to where I can't handle it anymore. And then it goes kaboom, creating a supernova. From there, depending upon the mass of the star, if it's less than 50, you get something about a neutron star. That meant the one that weighs about a ton for a teaspoon. Or it's a tight, compact star as the core collapsed down and repelled epically, and it spins dramatically. But if it's more than 50 times the mass of our sun, it keeps going and going and going. The core keeps collapsing and collapsing and collapsing to create a black hole. So that's where your black hole comes from. It's basically these huge superstars where the object becomes so massive as the core is collapsing that it keeps going and going and going. So how do we see these black holes? Because obviously by their name, they're black. And when you're comparing them to the background of space, you can't really see them. We can only see their effects on objects that get close to them. So the way we're able to see them is if a star is nearby and it's being engulfed by a black hole, we're only able to see them through the radiation that they produce out in terms of X-ray and gamma ray radiation. because as it's eating stuff, radiation is being burped out, as well as the jets produce these kind of radiation and much more. So we're only able to see them by the result of objects that are close to it and or things that the black hole starts to develop. We also sometimes see around a black hole a disk of some kind, as material is slowly either orbiting the black hole and or slowly being engulfed by the black hole. And or the way we also know that sometimes we can detect them is if objects orbit them. Like we discovered in the early 1990s that objects like stars were going around this one particular place in the sky, but there's nothing there. Yet they orbit that one particular spot. And we don't know why. And it was proposed, given the mass of these particular stars that are going in orbit around this particular place and how fast they were orbiting, they were able to estimate that this blank place that they were orbiting had to be a black hole. So, as cool as they are extremely dangerous. And here is why they are dangerous. So suppose that you weigh about 150 pounds here on Earth. If you were to be sucked into a black hole with this amount of gravity that it has, it would be 200 trillion pounds. 150 pounds would equate to 200 trillion pounds. That you're basically being squished. On top of the fact you have an accretion disk around the black hole, which is material that's just flowing around, and it's chaotic in the accretion disk. And it's also very hot in some cases of the accretion disk. And if you were to go into the black hole, this is where forces start coming into play. It's really crazy to think. The amount of force that the black hole exerts on your feet is much greater than the force that it exerts on your head, just by even this distance. And because of that, it pulls on your feet more than it does on your head. So it causes your body to be stretched to a thin, like spaghetti strip. And then as your body starts to slowly go into the black hole, as your body is being stretched so thin, it starts ripping apart the atoms inside your body. And eventually the subatomic particles start to become adding to the mass of the black hole itself. Very super crazy. On top of the fact that you have what is known as Hawking radiation. Hawking radiation is basically a form of excess material or radiation emitting from the black hole itself, and is very lethal to humans. And obviously you don't want to be in the jets of the radiation, because usually it's the excess material that's being flung out into space plus high doses of gamma radiation. So you don't want to be in the jets either. So you want to be as far away from a black hole as possible to observe it from a safe distance. So as you can see with the green smiley face, you can look, but don't get near or touch. But fortunately for us, the nearest black hole is about 1,000 light years away. We're good. So this is the basic concept of black holes, what they are, how they're formed, and why they're so dangerous and so unique. Next time, I'm going to discuss about what makes our studies of the black hole and how we're able to learn so much more about black holes throughout the years, and where the concept of a black hole began. So if you have any questions or comments, leave it down in the comments below. If there's a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.